This afternoon, we've got a talk by Rory Kelly, who's going to give you some ideas about the supercomputing facilities and how we do things. And then Kate will take us through the practical session that we'll be running this afternoon, which we'll all be interacting with. So Rory, I'll let you take over and start. Thanks.
All right, well, good afternoon, everybody. It's fun for me to be back in person at a CESM tutorial. It's quite cool. It's been a couple of years, so I hope it's been a good morning for everyone. As Peter mentioned, I'm from the consulting services group. So we basically provide support specific to the HPC machines and the services related to HPC for NCAR. So I'm going to talk a little bit today. It's going to be a pretty brief talk, but we do have a lot of stuff on our website that goes into depth on a bunch of these topics. So, there'll probably be a little time for questions at the end, and if not, feel free to grab me at any point this afternoon too. I'll be around. So this is my last slide. I'm going to give you a heads up, my very last slide, but when I was making the slide deck, I decided to also make it my first slide because it's pretty good. It's, if you walk away with anything from my talk, that and also it's where you can go to submit like help tickets if you need help with anything. So I've circled the two important links up there in red. Docs takes you to the doc tree for the HPC support, and then help is where you would submit a ticket if you have a problem with something. So I'll get back to that slide at the end. So the things I'm going to talk about today are just the systems we have, how to sign in and use the systems, how to manage data on the systems, how to build software, how to submit batch jobs, and then how to customize your user environment a little bit. Like I said, this will all be kind of shallow information, so feel free to ask me later if you have any questions. The system you'll be using today, and what's currently kind of our main system, is Cheyenne. It's a little bit long in the tooth now. It's coming up on its last year of production, so the nice thing about that is it's fairly stable and well-known at this point too. So this will probably be the last year the tutorial uses Cheyenne. It's a 4,000 node cluster, and each of those nodes has 2 sockets with 18 cores. So there's like 36 cores on each of those 4,000 nodes. And they're split into 2 types of nodes: small memory nodes, which is the majority of the system. There's a little over 3,000 of those, and they have 64 gigabytes of memory. And then there's some that have twice the memory. About 800 of the nodes have twice as much memory. All of it's connected together by an EDR InfiniBand network, which was very fast when it first came out. It's getting a little long in the tooth like the rest of the system, but still works pretty well. Should be good for today. And there's 6 login nodes on the system. So when you actually access the system, you'll be placed on one of these 6 login nodes, and they have even more memory to accommodate users being on. On Wednesday, I think you'll use a system called Casper, which is kind of less of a system than like a collection of systems that are all very different. So Casper's tiny compared to Cheyenne, but if you just go back and see Cheyenne, very easy to describe. Casper's this big eye chart. It's like a mix of different types of hardware. So the bulk of it, the largest collection is actually kind of this third section down, 64 high throughput computing nodes. And those are basically just like where you would run any sort of small jobs. We don't want you running on login nodes, like simple serial, MATLAB type stuff is a good place for those. It's also got some collections of nodes that don't have GPUs used for GPU computing, but they have GPUs used for visualization. So it's got 22 of those. They're what we call visualization nodes. If you're doing something where you're making a lot of charts and plots and looking at a lot of graphics, those are the nodes you would want to use. It's got 10 nodes that have GPUs for GPU computing. You won't use those in the context of this workshop, so you don't need to know much about them other than the fact that they exist. Maybe it'll be relevant in your later computing life at NCAR. And then there's 4 nodes that handle an activity called the Data Research Archive, which again, you might use data from there someday, but it won't be important this week. And then the quick plug for the system that'll be replacing Cheyenne into this year. It'll be arriving sometime around October. It's Derecho, and it's actually, it's like from a node point of view, it's a little smaller than Cheyenne. There are fewer of them, but from a number of cores point of view, there are a little over twice as many cores. So And then in terms of like efficiency, it's a little more efficient. So it's something like 3.5 times faster than Cheyenne. Again, won't be relevant this week. It's just a little plug for it. If you're doing computing at NCAR later on next year or in the following years, if you or anyone you know is back for a tutorial in the future, it'll probably be on this machine. Okay, so logging in, first practical thing. And when I was driving down this morning, I did remember I took a slide out because I wanted to make a better screenshot. And then, yeah, I forgot to put that back in. So I'm going to verbally walk you through a piece of information that might be important later on. But anyway, to access the Cheyenne system, typically it's SSH-XY for X forwarding, -L your username, and then cheyenne.ucar.edu. That'll place you on one of the login nodes, one of the 6. I think most of you have done the homework from last week and probably have been on the system already. So I hope everybody's got that pretty ironed out at this point. The one thing I forgot to put a slide back in on is the duo authentication. So if you logged in before, you go in, you type your password, and then your phone gets a duo push and you click accept and you get on the system. Occasionally, for whatever reason, people can't get a good cell service connection somewhere, and so you can't get a Duo push, and you can still log on. There's a rolling passcode in the Duo app too. So there's a fallback method to authenticate. If you ever need to use that, the thing you do, you SSH in the same way, but if you can't receive a push, then you type your same passcode into the terminal, but you do a comma, and then you add the 6-digit code that's in the Duo app. So that's the thing I forgot to make a slide on. Hopefully it doesn't bite anybody today, but if it does, come find me and I can help you with that. Similarly, on Wednesday, if you need to get on Casper, same process, but it's casper.ucar.edu. And again, probably most of the problems we have related to the workshop are with doing graphical things. So like I mentioned back here, the -X and -Y are for X forwarding. They allow you to do this old 1980s style graphics forwarding called X11. You can see those little googly eyes in the corner of my terminal. That's one way to get graphical feedback from the supercomputers, but it's probably also the slowest and most error prone. So if you just need to do things like look at charts and plots and use graphical programs like MATLAB, there are some other ways to do it. I'm going to mention those briefly. Tiger VNC is one. So once you're on Cheyenne, we have a command called VNC server submit, and that will basically set up a VNC session for you. And that will let you launch like a full Linux desktop on Cheyenne, and you can have kind of an interactive Linux desktop, which you might be a more familiar experience with, and you can run graphical programs that way. So that's one way of doing graphics. Another one is a service called FastX. A few ways to access FastX. One is to connect to the VPN, and if you do that, then you can go to fastx.ucar.edu, port 3300 in a browser. And same thing, you can get a full Linux desktop and do interactive graphics. Both these methods are much, much faster than the X11 forwarding. So if you are doing something like running an interactive program, they're worth exploring. And then again, if you don't want to connect to the VPN, there are a couple ways to SSH tunnel and set up FastX over an SSH tunnel too. Again, I just want you to know that exists. You don't need to know the details. If it becomes important, come find me or submit a help ticket, and we'll show you how to set that up. Or, better yet, walk our documentation, because our documentation has a pretty good instruction set for getting FastX going. And then finally, this is kind of a workaround, but you can also display graphics back with Jupyter Hub. I would imagine a lot of you have interacted with Jupyter Hub or Jupyter Notebooks at this point in your life. It's basically a really sophisticated service to allow you to do interactive computation in notebooks, but it can also do really dumb things like help you look at pictures from Cheyenne. So one thing you can do is you just want to look at a plot you've made and you don't want to go to the trouble of X forwarding or anything else. You can just open it up. You can navigate to it in the Jupyter Hub browser and then click on it, and Jupyter Hub can display most image types. So that's a thing I do quite a bit if I just want to look at graphics. And again, that's jupyterhub.hpc.ucar.edu. You access it with Duo the same way. A few things we want you to know when you're on the shared login nodes is just that be aware there are other people on those nodes too. And so if you do something like try to run a model or some heavyweight compute process on the login nodes themselves, it makes it kind of slow for everybody else. And we actually have some automated scripts that'll probably end up killing your jobs. Not to be mean, but just to kind of try to keep the login nodes free for other people. So things that are good to do on the login nodes, like editing text with text editors, you can compile a small program, you can transfer data in and off the system, interact with the PBS, the job scheduler, which I'll talk about in a bit. Those are all totally fine things to do on the login nodes. But don't just do like some massive model run on the login nodes. That'll be reserved for the batch nodes. I'm going to talk quickly about the data storage spaces that you should have set up for your account. So the one, when you log into the system, you're in your home directory. That's a 50 gigabyte space and it's backed up. So, things you should keep there are like code that you're working on or files that you're going to be using to write a paper and you definitely don't want to lose. Because if you accidentally delete things out of your home directory, it's fine. We have snapshots throughout the day. Every hour your home directory is backed up, and then at longer durations over the course of a week and a month, we keep dailies and weekly snapshots as well. So that's a very safe space to store data, but it's pretty small. It's only 50 gigabytes, so don't put all of your input data sets there. Just important data you want backed up. There's a larger space called work. That's a 1 terabyte space. It's not backed up, but it is yours to do with as you want. You can fill up the 1 terabyte. We don't delete anything out of there. It's your space. But again, it's not, if you delete a file accidentally out of your work directory, it's gone forever. No backups of that space. So that's a place like where we recommend putting, executables, compiled code, models, but stuff that you could recreate if it got lost. The Scratch space is where a lot of your model runs will happen. And it's a pretty big space. It's 10 terabytes. And on occasion, we will make it even larger than 10 terabytes. If you're working on a project that needs extra space, we can expand that space. The difference between Scratch and work, Scratch is larger, but the other main difference is that we purge it after 180 days. Any file that is older than that will be automatically deleted. And that's how we keep that space, available for people to use. So don't keep anything important there, or at least not for a very long time. If you have some data you create that's important to you, make sure you move it out of the Scratch space to somewhere else that's better for long-term storage. We also have some project space. And again, this isn't something you will get by default, but if you're working with someone on a project, they probably have been allocated project space. So you may have a project space. The size of those varies, and they're kind of managed by the labs and the people who have an allocation. Again, not backed up, but not purged. And then Campaign Store is a similar thing. It's, you'll get that by request for a specific project. It's longer term storage for like 3 to 5 years. And then after 5 years, there will be pressure on you to delete it. It won't be automatically deleted, but it will very much need to be gone. So again, that's not going to be important this week, but if you're doing other computing here at NCAR, you may end up using a campaign storage space for longer term storage. Collections, again, these are just data sets that we host on the machine because they get used a lot. CMIP6 is probably particularly relevant to this crowd. So there's some subset of the CMIP6 data on Cheyenne locally, so you don't have to download it. And probably the important thing to know about that is just that if some data set you need is not local on Cheyenne for CMIP6 requests, we have this address at the bottom where you can go and request a particular data set and we'll put it on the machine for you. So getting data on and off the machine. Oh, I should mention, I don't know if I explicitly said that, all of these spaces go by the acronym GLADE, the Globally Accessible Data Environment. So we call the file systems in aggregate GLADE. So getting data in and out of GLADE, if you're just transferring small files like SCP or SFTP, if you know what those are fine ways to do it. If you need to transfer some large amount of data and you don't want it to take forever, Globus is the service we recommend. Again, not important this week per se, but just know that that exists. If you have some large data set you need to get onto the machine, you should be using Globus. So look at the documentation if you need pointers on how to do it. But Globus transfers to and from Cheyenne are quite quick. The bandwidth is much better. Okay, so environment modules, once you're on the machine, are kind of the way we manage software. So if you did the homework, modules were probably being used sort of invisibly, under the covers for you in some of the scripts that were set up for you. But the module commands are basically how you load software into your environment, how you get rid of software in your environment, and how you use particular versions of software. So the things we provide access to are things like compilers and debuggers, libraries like NetCDF that help you with data formats, things like that. That's all managed by these programs called modules. One important note is that Cheyenne and Casper have similar but not identical collections of modules because they're different machines. So something may exist in one and not in another. Quickly, the commands you need to know about in modules. To load some piece of software, you would use module load, and to unload it, you would unload it. So for instance, to be concrete, if I wanted to load version 18 of the Intel compiler, I would say module load, then I would say Intel/18.0.1, that would load a specific version for me. Module avail will show me all the things that I could currently load. And module list would show me what I have loaded. So module avail, the way it works, kind of the idea with modules is it doesn't allow you to load everything at any point. It only allows you to load software that's compatible with stuff you have loaded currently. So for instance, if I have the Intel compiler loaded and then I say module avail, the things it shows me are only things that will work with the Intel compiler. And if I unloaded the Intel compiler and loaded some different compiler like the GNU compiler and then did module avail, it would show me different things. In some cases, they'd be the same thing, but they'd be compatible with GNU instead of Intel. So this little tree on the right-hand side of the chart sort of shows like a dependency graph of getting through the module tree system. So compilers are sort of the main thing. Like if I loaded an Intel compiler, then this middle box would show me software that was compatible with the Intel compiler, and then MPI libraries are another level of dependency. If I loaded some particular version of MPI, then it would show me stuff compatible with those two previous levels. So all that is to say, when you do module avail or module list, it's only showing you some subset of the entire available software, but it should all be some subset that works well together. So if you wanted to blow everything away in your environment, you do module purge, and that gets rid of everything. And then you can do a module reset or a module restore. Either of those would kind of load your default environment back. And then if you want to search for things in the module tree, like if you wanted to say, oh, do these guys have netcdf on the system, you would use the spider command, and that kind of walks the entire module tree and returns all the results that are relevant. So you would say module spider netcdf, that would show you all the versions and then give you some hint about how to load a particular version that was useful to you. And then module save and module restore with a name will allow you to save sets of modules. So like, for instance, if you had a particular set of modules like that you used for doing some post-processing in R, then you could module load R and netcdf and all the software you needed. Then you could save that as like a named set, like my analysis, so you module save my analysis. And then the next time you wanted to load that same set, instead of doing it individually, you would say module restore my analysis, and it would load everything all at once. So again, real brief, ask me later on this afternoon if there are questions, but that's kind of the small set of module commands you need to know to navigate the system. Again, just don't put modules in your like dot files, your TCS HRC or your profile. That tends to lead to a lot of problems. So if you want to have some different default set of modules that you use all the time, use those module save and module restore commands I just talked about. Okay, so quickly, just the types of stuff we have on the system under those modules. We have different compilers. Intel is kind of the default one, but GNU and PGI and some other even more esoteric compilers are available. We have debuggers and performance tools. DDT and MAP are our default ones there. MPI libraries. MPT is the one supplied by HPE that built the system, but Intel MPI and OpenMPI are available as well. Common IO libraries like netcdf and pnetcdf. We have analysis languages like Python and Julia, MATLAB R, and then convenience tools. So NCAR compilers, things like that are kind of like basic helper programs that we provide that might make your life a little easier. So there's a lot of stuff there. Just module spider, module list, module avail if you want to see what's on the system. Okay, when compiling software, so most of what you're be doing this week is using scripts, CESM scripts that are sort of already set up to compile stuff for you. And so it'll be pretty convenient this week. But if you do end up needing to compile your own programs outside of CESM, just some considerations to think about. This NCAR compilers module is a thing we supply that will do linking and including of libraries sort of automatically for you, and can just save you a lot of time from trying to figure out the directories and include paths and link paths you need. So that's a good one to have loaded. When you use MPI, it's helpful to make sure you're running with the same version that you use to compile. So if you compile a program with a particular version of MPI, It's nice to put that in your job submission script to make sure you're loading the same version. And then Cheyenne and Casper, because Glade is the file system on both machines, but they are actually different systems. They're not 100% compatible. If you compile something on Cheyenne and run it on Casper, it'll probably work, but it could be slow. And if you go the other way, if you compile on Casper, it's likely to not work on Cheyenne because Casper's got kind of a newer instruction set. So you might get some weird errors. So just, compile software separately for the two systems, even though they share a file system. Okay, batch jobs. So, I urged you not to use login nodes for large jobs. So where do you run a large job? You should run it on one of the 4,000 other nodes we call a batch node. The PBS is hopefully a system you used at least to do the homework. So it's basically what schedules work and finds resources for you to run your jobs. The basic flow of how you use that from your workstation, you're SSHing into Cheyenne on one of the login nodes, and then you use these PBS commands, qsub, etc., to submit a job. It goes off and it runs on a batch node, and then later you check the results. We'll skip over that. That's not super important. Here's some examples of job scripts. The one on the left is Cheyenne. The one on the right is Casper. Again, most of your interaction with the batch system this week is going to be via the CESM scripts that do like the submission for you. So you don't need to spend a lot of time looking at this, but these scripts are being created under the covers and submitted to PBS. So you'll probably see stuff like this, and it's helpful to understand what's happening under the hood, what the CESM scripts are doing for you. So just briefly, just looking at Cheyenne there, the example script, all these things that begin with a # then PBS, those are just comments that the batch system reads. The -n names the job. The -a is your project code. You set an environment variable, most likely for CESM, to get that set. The -j and the -o are just telling it where to direct output to. The -q is the queue that you're running in. Regular is what you would normally use, but there's some special queues that'll be used for you this week. But we do have to, if you're running stuff outside of the tutorial this week on our systems, there are different sort of priorities of queue. There's regular, and then there's a premium queue, which is more expensive, but your job will get through the system faster. Then there's an economy queue that when you don't have allocation, things can still run there, but it takes longer for them to run. Then the last lines there, the wall time is like how long you expect your job to run, and the -l select says how many resources you're expecting to use for your job in terms of nodes. So that line there is asking for 2 nodes with 36 processors on each of the nodes. Again, that's just sort of so you know what's happening under the covers, but I don't think you'll need to edit batch files this week unless something goes wrong, which it usually does. Then you do it. Yeah, exactly. The basic commands to interact with the scheduler, though, and again, these happen for you, but you probably, will want to do these at some point in your life. qsub submits a job. qstat tells you the status of your job. You probably will be using that command this week to just see if your job is still waiting to start, or if it's running currently, or if it's been exited. If you accidentally run a job and you weren't quite ready and you want to delete it, qdel is how you delete it. qinteractive is helpful if you need to interactively get on a batch node just to, like do something you would do on a login node, but it's going to be a little too like a compile job. You want to interactively compile. If you just do qinteractive and then -a with the project code, it will schedule an interactive session for you that feels like being on a login node, but it's on a node entirely to yourself. So you can do whatever you want on a job if you run it that way. And then qcmd is a command that schedules work to run on a compute node, and you can do anything. So if I wanted to do an ls from a compute node instead of a login node, I could say qcmd, again, -a with the project I want to be charged. The -- separates what you want to run from the command itself. So anything after the -- is what will go off and be run on a compute node. So to do an ls, I would say qcmd -a my project code -- and then that ls command will get scheduled by the batch system, and it'll go off, and when a compute node is available, it'll run an ls on a compute node and return the results to you. So ls is not a good use of a compute node per se, but any sort of work you want to run interactively that way can be done with that command. We'll skip that. Thing to know, it comes up somewhat frequently if you just have like a bunch of serial tasks that you're stepping through, like you want to do the same thing on 100 different files. We have an easy way to script that. I won't go through the details, but it's just called a command file. So if you have that type of workflow, know that you can look that up in our documentation, look for command files. It's just kind of an automated way to step through repeated data tasks. A note about Casper, as I mentioned when I gave a brief overview of the systems, Casper is really heterogeneous in the node types, number of GPUs, type of GPUs, maybe there are no GPUs, type of processors, there's 2 different types of processors, all this stuff. So you need to be really explicit on Casper if you want a particular type of resource, like in this example script, the important line dash there, like this is a GPU job where I know I want a GPU. So you have to specifically request it. So here I've said I want 4 GPUs, I want to use 40 gigabytes of memory, and I want those GPUs to be of type V100. So again, those details aren't important to you. It's just important to know that if you are using Casper and if you want to use something specific, you have to request it because there's just too much variety of hardware available. I guess I talked about these already. Again, these are just the queues that are available. So premium, regular, economy. Share, I guess, is the one I didn't mention. So share is if you want to not take up an entire node. Premium, regular, and economy will give you a minimum of 1 entire node all to yourself. So you'll be charged for 36 cores times the amount of time you use it. If you want to use less than a full node, you can use this share queue and say, I just want 2 processors, and then you'll be charged for 2 processors instead of 36. This is just a way to customize your startup files if you want to do things. If you want to have things like aliases that are slightly different on Cheyenne and Casper, you can put this sort of logic in your startup files. So again, your startup files they'll appear on both systems because the file system is the same across both systems. So you can do something like check for the host name when you're logging in. And if the host name equals Cheyenne, then set my path to this. But if instead I'm on Casper, do this. So again, that's a capability that exists. Ask me if the details become important. SAM is where you would go if you want to see like how much you were charged for a job that you ran. So that's the accounting system account manager. So if you run a big model job and you want to know how much of my allocation did that use, you would log into SAM. sam.ucar.edu is the website. It's the same Duo authentication to get into the SAM system. You can do some other little convenient things there, like you can change some of your user settings. If you want to change your default shell, you can do that through SAM, but it's mainly to see a history of your jobs and charges. And then here we are back to my first and last slide. This is where you go for help. So it's in the past, we had sort of people on desk duty physically in person. It's kind of gone away with the pandemic. So we are occasionally physically present in the Mesa lab, but this is the easiest way to get a hold of us right now for sure. arc.ucar.edu and then filing a support ticket. If you need to talk to us in person, it's always easy to file a support ticket and say, hey, can you give me a phone call or can you set up a Zoom meeting? And then we can do face-to-face and interactive stuff that way. So that's it. If there are any questions right now, I can take them. And if not, I'll be around all afternoon and I'm happy to talk to you later on.
Great. And if you wanted to ask a question, just go to the mic so everyone can hear you.
Hi, I have a question about Cheyenne being taken offline, like you said, is going to soon. So if we've been doing work on Cheyenne in the past and we have files and things that we've built up, are those going to be automatically migrated to whatever new system there is, or?
Yeah, it's a little, so the Glade spaces, so Glade Home and Glade Work and Project, all that stuff will continue to exist for some period of time. So derecho, the new system, will show up this winter. It becomes generally available around March of next year, and then it'll overlap with Cheyenne for 6 months. So both systems will be online for 6 months. Those Glade spaces will stay around for a while, and they'll be available on derecho and Cheyenne at the same time. So if you've got a file right now on Cheyenne somewhere on the Glade system, when derecho comes online, the same file will still be available in the same location, but then eventually they will probably go away and will require manual migration. But there'll be a lot of heads up and warning if something requiring, if your files are going to go away and you have to take some action to prevent that, you'll get a lot of heads up and a lot of warning. So don't worry about it. But yeah, eventually the Glade file system will kind of be not gotten rid of, but it'll be also replaced because the hard drives that it was procured with, that stuff ages as well. So it'll be updated and there'll be some combination of automatic and manual intervention probably to move files. The one thing that will be different on derecho is the scratch file system is totally separate. So the files that you have, you'll still be able to access the Cheyenne files, scratch file system from derecho while Cheyenne's around, but not the other way. So derecho will have its own scratch file system that will not be available from Cheyenne.
Any other questions? All right, thank you, Rory.
Yeah, absolutely.